Cool. All right. So let me go through part A. I'll do a quick kind of recap on the calculations, and then I'll go through the excellence criteria for this section. Do I have the assessment? Check my sensitive. What was I going to say? Right. I know you guys are very multitasky, but when I'm giving these notes, I wouldn't suggest trying to multitask because then you're going to get really confused and not know how to do these calculations. Just so you guys are aware of what I'm planning for our deadlines. So today I'm doing the excellence bit. Thursday when I see you guys, I will give you a practice version for part A. That will be on the purple piece of paper so you guys can attempt it and see what you guys can do. And then Friday, I will give you feedback for that, and I think the rest of the session for study for Part A. Part A, we are going to be assessing on Monday. So a week from today, we're going to start the assessment, and we're just doing that Part A section. I have to say that Part A is probably the most challenging of the 4 parts. So do put the work and the mahi into it. Also be mindful, you do need to pass all sections for your grade in order to get the overall grade the same way. It's not going to be like ion identification where I give you the better of the 2 attempts. There's just the 1 attempt or a whole new further assessment opportunity because of the way this is now structured. So less flexibility in it. There's also some good news about Part A that I'll explain at the end. All right. Just as a reminder, I do have assessment style questions that I put on my Google site, which is these guys here. I haven't printed it out because I don't think you really need it printed out. Be mindful, I also put the answers online as well. So you can check your work. You don't have to wait for me to check it. You guys can check it yourself. I've done all the math already last year, so you can do it. What else did I want to add? Yeah, that's mainly it. Okay, so let's talk about Part A. I will do a quick recap of how to do the calculations because I know some people are kind of iffy on them. So be mindful that when we are looking at one of these practice questions, there are multiple different components. The first component, or I should say first component for Part A, is that you do an experimental test of your 2 solutions. You take a mil of your acid, and then you see how much base you need in order to neutralize it. So in this example, question 1, you had 1 mil of acid, and in order to neutralize that 1 mil of acid, you need 8 mils of base. Now my question for you, as a quick kind of checkpoint to make sure you understand what we're doing and why, which of these 2 solutions is more concentrated, the acid or the base? The acid, because you don't need as much acid to neutralize the base. So the base is a weaker concentration. Okay? So, also to keep in mind, if I was to do the titration with these undiluted solutions, or this undiluted solution, I would have to use 10 mils of acid as a minimum, because that's the smallest pipette we have, and I would have to use 80 mils of base to neutralize that. So that's not okay. That's refilling the burette. We don't want to do that. So, what we then need to think about is how diluted I need to make that solution and how much of that diluted solution I need to do the titration. So I have my stock, I have my pipette, I take out some of that stock, I put it into a flask, I then fill the rest of the flask up with water, and that then dilutes it. I then have to ask myself, how much of that diluted solution do I need for this titration? Because I'm going to be putting that diluted solution into my flask as my acid. Are we okay with that so far? So first thing you do is you read the question and you look at see what pipette sizes I've given you and what flask sizes I've given you. I have given, in this example, 10 and 25 as your 2 pipette sizes, and I've given you 100 and 250 as your 2 flask sizes. So my first option is I take 10 mils of the stock, I dilute it into 100. That's a 10-fold dilution. All I do is 100 divided by 10, 10-fold. So that means that my new solution is 10 times less concentrated than my original stock. Are you okay? Yeah? Okay. Other option is you do 25 into 100. I do 100 divided by 25. That's a 4-fold dilution. So it's 4 times less concentrated. 10 into 250, 250 divided by 10, 25-fold dilution. 25 into 250 divided by 250 by 25, 10-fold dilution. So those are my 4 options. 2 of them are the same. So I have basically 3 choices on how I dilute my solution. Are we good so far? All right, the next question is, with my diluted solution and the amount of diluted solution I use, how much base do I need from my burette? So that's the next question we're trying to ask to make sure we have a good method. The way we figure that out is by that table that I made. And what we're looking at is two factors. The first factor is my aliquot volume. So how much of the diluted solution am I using? Basically, how much am I putting into this flask here? And then the second question is, what dilution factor am I using? So we have this equation here that will calculate out our titrate volume, which is how much is coming out of the burette, aka how much is coming out, or sorry, how much base do I need? So if I put this into a calculator, I take the aliquot volume, which is this guy over here, I multiply it by the desired ratio, which is this number over here. So 1 divided by 4, 1 divided by 10, 1 divided by 25. Those are my choices. And then I divide it by my actual ratio. My actual ratio is this first bit here, which is 1 divided by 8. Okay? I don't know if I have my phone. I was putting in some numbers to show people how to do the calculation in their phones. Obviously, you guys would have calculators, but that's what it would look like on a calculator. So that is my aliquot volume multiplied by the dilution fold. So that's 25 fold, which is that over here. And then divide it by the actual, which is the 8-fold here. Okay? I plugged all that into the calculator, so 25 and 25, and the answer I got was 8. So I would need 8 mils of base in order for that reaction to occur. Okay? Now let's go on to the excellence criteria and some of the stuff we were talking about. So something to keep in mind is we need to justify the experiment in order to get excellence. Now the good news for excellence, and I'll show you this on the marking schedule, and this is on your yellow piece of paper, this bit down here. So we've covered the achieve the merit section. Someone asked if I could quickly go through the proposed procedure again. So just keep in mind with the proposed procedure, you are basically just explaining and filling in the blanks to what you've selected up here. So in this example I did on Thursday, I said we'll do a 10-fold dilution, which is that guy here. We will take 10 mils of that sample, which is that over here, 10 and 10. In order to make this, I would do 25 of my stock into 250. So I'm explaining here how I did my 10-fold dilution. There are multiple ways to do my 10-fold dilution. It's up to you. I then say again how much of the diluted stock I'm going to need. I state what the color change I'm looking for is, and then I state how much is going to be needed from my base. So this, you'll be given, this is fill in the blank. So doing these calculations, filling in this bit here, that gets you up to a merit level. It's actually quite a big jump from achieve to merit, which is usually the case in a lot of the chemistry standards. If you make a mistake somewhere, that's usually going to just drop you down to an achieved instead of not achieved. If you do the work, you should be fine. Excellence then is explaining your proposed procedure and why is it accurate and why is it valid and how do you know it's going to be precise, etc., etc. So one of the things that we talked about on Thursday, and you probably don't have time to copy it down, but it is scanned, so you can grab it later, is explaining why you dilute the stock. So I'm basically trying to assess, do you understand what you are doing and why you are doing it? So the first thing that you could write about is, why do you need to dilute the stock? Why can't you just use the original sour cream solution? Well, the reason why is because if I don't dilute it, and I scale it up for titration, I would need 100 mils of my base, which is not going to work because my burette only goes to 50. Okay? So that's my first layer of justification that I can use to show me that you understand what you're doing and why. We probably don't have time to copy this down, but it is scanned, and I'll scan it again for this lesson. All right. Second thing you guys can write about is you can explain to me why you have to have a certain volume for your titrate volume. So basically what I'm looking for is, if you guys remember, I'm just trying to find the right piece of paper. Here it is. And I should probably find my phone so I can get the notes out. The question is, for the excellence, why is my lower limit set to 10 and why is my upper limit set to 25? So that's the next 2 points you can make. And let me just pull up my notes so that way I can actually remember what I said last year when I taught this. Oh, I gotta dig around for it. This was fun. Should have had this open beforehand. Luckily, I know where it is. I'm a very organized person. Last year's part A. There we go. All right, cool. So first thing we're gonna have, or sorry, second thing that I would explain is my lower limit. So with your lower limit, you're basically explaining why can't you go below 10? Or why you shouldn't. Is the big question we are asking. So the reason why has to do with the error that is in our equipment. So in our burette and in our pipette, there's about a roughly 2% error in the equipment. That also kind of factors in human error as well, like are you reading at the bottom of the niskets and things like that. It's just saying a rough idea. So something to keep in mind with a 2% error, if I was to translate that across, that would be 0.2. And what we're thinking about is the size of, that's 0.2 milliliters is basically what we're saying. So with a 2% error, it's 0.2 above or 0.2 below what it should be, is that error range. We have to factor out what that 0.2 milliliters is based on your titrate volume. So if I had a titrate volume of 10 milliliters, and there's a 2% error, so we're saying that we could be above or minus 0.2 mils, and I times that by 100%, that means you have 2%. So that's the error that you're getting. That is an acceptable amount of error to carry. Anything lower than 10 is going to result in more error. So for example, if I did 0.2 and I divided that by, say, 5, times it by 100, I now have 4% error. So it's now a larger percentage. So the smaller the number, the larger that error becomes. So what you should be writing about is basically your selected titrate volume, what would you get error-wise? And in my case, because my titrate volume is 10, it would be a 10% error. If I had selected this guy and I did 25 mils as my titrate volume, that would be 0.2 divided by 25 times 100. I would now have a 0.8% error. So this is actually going to be more accurate than this one. So those are the things you have to balance between. So if I use a larger volume, then the 2% error, the error from the equipment is then minimized. So that's kind of things to think about is why are you using the lower limit. So this here is just talking about the volume of the titrate. So you can see what your percentage error. The next thing to think about is why is there an upper limit? So why shouldn't you use more than 25? So basically we're trying to explain the upper limit. This is lower limit. This here is upper limit. So upper limit, just watching my time because I know we're running out. Upper limit is a lot simpler. In that case, we are just talking about wastage. So 2 reasons. First reason why I wouldn't want to go above 25 is that I would have to refill my burette more often. If I have 25 as my upper limit, I can do 2 titrations. So 25 is enough for 2 titrations. All right. That also means I have to refill it less often, so less error. Okay? Last thing you can talk about is how many times can you repeat the experiment? It's worth staying the extra few minutes if you can, because I don't want to stop it here. All right, so sorry, really sorry. All right, if you guys remember, I said I was making 250 mils. And I need a 10 mil for my aliquot. So if I was to do this division, I would be able to repeat the experiment 25 times. Which means I can collect a lot of data and find the outliers. I'm still recording it, in case you guys are walking out. If you're walking out, I'm still recording it. Oh, yeah, just drop it down on my table. Therefore, you have more accuracy. Sorry, more precision. Actually, more precision? No, more accuracy. Okay? So, one of the other options I had was to do 10 into 100 and make a 100 mil stock. With that, I would only get 10 experiments. The other thing to keep in mind is we want to only dilute this solution once, because every time you dilute the solution, it's going to be slightly different. So, want a lot of stock. So, you only dilute once. Each time you dilute, it is slightly different. So again, that helps with that accuracy. Okay? That's basically it for the justification. I don't need all of that for the justification, but the more you put, the more evidence I have to work with. The good news about this is that if you muck up Part A's justification and I don't give you an excellence on it, you still have a chance to get it in Part D. Okay? So I can collect this evidence twice, basically. Okay? So it gives you 2 chances for that. Cool. That's it. Sorry about that.